Bright Duty. Every student matters.
Let's move to these questions. ABCD is a quadrilateral in which PQRS are midpoints of sides AB, BC, CD and DA. AC is a diagonal. Show that SR is parallel to AC. Okay. Now, the given information that PQRS are midpoints can be represented by these marks. So, P is a midpoint, so I'll mark it like this. So, these two segments are equal. Q is a midpoint, so these two segments are equal. R is a midpoint, so this segment is equal to this segment here. S is a midpoint, so let me mark it by 4 bars here. Right? So I have marked the figures. Now it is easy for me to visualize the problem. So first part, SR is parallel to AC. It can be easily shown by using midpoint theorem in triangle DAC. I can see that S is midpoint of side DA, R is the midpoint of side DC. So this implies by midpoint theorem in triangle DAC, I can say SR is parallel to AC. I can also say that SR is half of AC, right, by midpoint theorem itself. So first part is done. Now PQ is equal to SR. So if we have to show that PQ is equal to SR, we can show that PQ is half of AC by using midpoint theorem. Which part is this? This is second part. Okay. So for second part, in triangle ABC, P is the midpoint. P is the midpoint of BA. Q is the midpoint of BC. So by midpoint theorem, what can I say about PQ and this side AD here, AC here? PQ will be parallel to AC and PQ will be half of AC, right? And if PQ is half of AC, SR is half of AC, then PQ will naturally be equal to SR, right? PQ is equal to half of AC, so you can say it like this: PQ is equal to half of AC, but we know half of AC is SR, so let us put it equal to SR. So now you see that PQ is equal to SR, right? So this part is done. Now notice PQRS is a parallelogram. What we need to show is that PQRS is a parallelogram, which is very easy for you to show, that PQ is equal to SR. This is one of the statements that you will make, and PQ is parallel to SR. Why is it so? Because PQ is parallel to AC, SR is parallel to AC. So PQ will be parallel to SR also, right? And once you have said these two statements, that PQ is equal to SR, PQ is parallel to SR, so PQRS is a parallelogram. PQRS is a parallelogram. If you want to write the reason here, you can say, if one pair of sides of a quadrilateral, is equal and parallel, it becomes a parallelogram. It is a parallelogram, right? This we have studied in the previous lecture, that if one pair of sides is equal and parallel, then it is a parallelogram, right? So I've shown all three parts here. So let's move to the next question. ABCD is a rhombus. PQRS are the midpoints of sides A, B, BC, CD and DA. Show that quadrilateral PQRS is a rectangle. Okay, from here we saw that if you have any quadrilateral and you join the midpoints of all these sides, the quadrilateral made inside is a parallelogram. So till now we have seen that if you take any quadrilateral and you join the midpoints of its sides, you will get a parallelogram inside. Now this outer quadrilateral is a special type of quadrilateral, it is a rhombus this time. So let me take a rhombus outside, right? This ABCD is a rhombus. That means AB is equal to BC is equal to CD is equal to DA. Okay, now I take PQRS as its midpoints of the sides AB, BC, CD and DA respectively. Okay, show that quadrilateral PQRS, that is this quadrilateral here. Let me make it using another color. PQ, QR, RS, PS. Okay, so this PQRS is a rectangle. We need to show this, right? So out of the given information, what can you observe? We can observe that AB is equal to BC equal to CD equal to DA. This much is given. So we can say that their halves will also be equal. So AP will be equal to PB and it will be equal to BQ also, because if I take their halves, they will also be equal, right? AP is half of AB, BQ is half of BC. So these segments, all these segments are equal to each other, right? These segments are also equal. Now we need to prove that this quadrilateral inside is a rectangle, rhombus outside, and this segment is AP is equal to AS. So I am starting with this. AP is equal to AS. So I can say this angle, if this angle is alpha, this angle will also be alpha. Okay. So can I make a statement here that quadrilateral PQRS is a parallelogram? Can I make this statement? Yes, because if there is any quadrilateral and I join its midpoints of every side like this, the quadrilateral inside will be a parallelogram. I have just proved it here in the first question. Okay, so what can you do is, if you want to prove it again, you can prove it by using midpoint theorem, that this line will become parallel to this line, right? And this line will be parallel to this line, and this PS is half of BD, QR is also half of BD, so PQRS is definitely a parallelogram. So I am starting my question that quadrilateral PQRS is a parallelogram. I assume you can easily prove it just by looking at the previous question. Now I just need to show one angle of this parallelogram as 90 degrees and it will definitely be a rectangle. So I need to show any one angle of quadrilateral PQRS equal to 90 degree. If I can do that, then I can make this statement that PQRS is a rectangle. I hope the question is clear to you. Now I have shown you that segment AP is equal to segment AS, hence these two angles are equal because this is an isosceles triangle and base angles are equal. Another thing that you can see here is that AB is parallel to CD, AB is parallel to DC. So this angle A and angle D are co-interior angles. So angle A plus angle D is equal to 180 degrees. This much we know, right? And one more statement and then this question is done. This segment DS is equal to segment DR, right? So if this angle is beta, what will be this angle? This will also be beta because these are base angles of isosceles triangle DSR. Now let me make this statement. This triangle has got three angles, alpha plus angle A. This triangle has got three angles, beta plus beta plus angle D, and sum of these angles is 180, sum of these angles is also 180, so that their total sum is 360, out of which angle A plus angle D is 180. So these two angles make 180 degrees. So if I subtract 180, I can say 2 alpha plus 2 beta is equal to 360 minus 180, that is 180 degrees. And what can I say about alpha plus beta? Alpha plus beta will be equal to 90 degrees, right? If I divide both sides by 2. So alpha plus beta is 90 degrees. Once you can see that alpha and beta collectively are equal to 90 degrees, what can you say about this angle here? If this angle is theta, then these are angles on one side of a line, right? So these collectively will be a straight angle. So alpha plus beta plus theta, we know alpha plus beta plus theta will be equal to 180 degrees. Alpha plus beta is 90, so theta is equal to 180 minus this 90 degrees, right? Then this angle is 90 degrees, okay? And if we can prove that PQRS is a parallelogram and one of these angles is 90 degrees, now I can definitely say that PQRS is a rectangle, right? Now some of students might wonder that only one angle is 90 degrees, why not all angles 90 degrees? When you say that one angle of a parallelogram is 90 degrees, all other angles become 90 degrees automatically, you don't have to say that. So we are saying minimum things, so that we have to prove minimum things for a quadrilateral to become a parallelogram, right? Or a parallelogram to become a rectangle. Otherwise you can notice that opposite angles of parallelogram are equal, so this angle is 90, so this angle will also be 90. Now you can notice that this is co-interior to this angle, so this will also be 90 because their sum has to be 180, and this is opposite this angle, so this will also be 90. So it is clearly a rectangle. So I want you to write these statements yourself, okay? Now ABCD is a rectangle, PQRS are midpoints, and we need to show that PQRS is a rhombus. This time we have got the outer quadrilateral as a rectangle. So A, B, C, D is a rectangle, and the inner quadrilateral made up by joining the midpoints of these sides, we need to show is a rhombus, right? Now ABCD is a rectangle. This segment is equal to this segment, P, Q, R, S. Why do I say that? Because P is a midpoint of AB, so these segments are equal. BQ is equal to QC, right? Now you need to notice that this is a rectangle outside, so AB is equal to DC. AB is equal to DC. Why? Opposite sides of a rectangle, so their halves will also be equal. Half of AB will be equal to half of DC. This is half of AB, this is also half of AB, this is half of DC, so it will be equal to PB. So I am marking it by 2 cuts here. Similarly this will also be equal because R is the midpoint of DC. Similarly this segment will be equal to this segment, and this segment will also be equal to this segment. Now I have marked my figure and I know which segment is equal to which segment. Another thing that I know is that quadrilateral PQRS is a parallelogram. Can I start my question with this? Quadrilateral PQRS is a parallelogram. Now if this question is a like very short answer type of question, right, then you start with this, that PQRS is a parallelogram. If this is a, let us say, 6 marker or 5 marks question, then you can prove that PQRS is a parallelogram. How will you prove it? You need to see the first question. You will just take this diagonal, and by midpoint theorem you will say that this line is parallel to this line is parallel to this line, and these two lines are equal also, right, by using the midpoint theorem. We proved it in the first question. So I'm starting this question by saying that PQRS is a parallelogram. So when would a parallelogram become a rhombus? If I can prove that its four sides are equal, right? All the sides of a parallelogram are equal. Now, when I say all the sides, when PQRS is a parallelogram, I already know that PS is equal to RQ, right? Opposite sides are already equal. If I can say that PS is also equal to SR, it is enough to prove that PQRS is a rhombus. So, if I can prove that adjacent sides of a parallelogram are equal, then this parallelogram will become a rhombus. Okay. So, let us start the question by to prove with the vision to prove that PS is equal to SR. If we can do that, we can say that PQRS is a rhombus. Now, you notice that this angle here is 90 degrees. What can you say about this angle here? This is also 90 degrees. Why? Because these are angles of a rectangle, right? Rectangle has got all angles equal to 90 degrees. Now notice these two triangles, this triangle and this triangle. Just by looking at the bars here or the marks here, you can see that these two triangles are congruent, right? By side angle side angle side congruency rule. So now you can write it yourself, or let me write it for you. In triangle APS, in triangle APS and triangle DRS, what can you say about the sides? AP is equal to DR, AP is equal to DR. Which other side is equal? AS is equal to DS, AS is equal to DS. And what can you say about the angles? Angle A is equal to angle D, angle A is equal to angle D. So by side angle side congruence rule, you can say triangle APS is congruent to triangle DRS. This triangle here is congruent to this triangle. So by CPCT, I can say PS is equal to SR. PS is equal to SR by CPCT. Now once you say this, now you can say that PQRS is a rhombus. Why? Because we have proved that PQRS is a parallelogram. So that means PS is equal to RQ here, right? PS is equal to RQ. We have proved that PS is also equal to SR. So obviously this is equal to this is equal to this, and PQRS being a parallelogram, SR is also equal to PQ here. So all four sides are equal, hence PQRS is a rhombus. And again, I want you to write all this information by yourself. So I am just saying that PQRS is a rhombus. What you need to write is that if we have got a parallelogram and we can prove that adjacent sides of a parallelogram are equal, then it is a rhombus. Okay, hence PQRS is a rhombus, right? Now ABCD is a trapezium with AB parallel to DC. So this is parallel to this. BD is a diagonal. Okay, DE is the midpoint of AD. How do I show that? That this segment is equal to this segment. Okay, a line is drawn through E parallel to AB, intersecting BC at F. Okay, show that F is midpoint of BC. This question should be pretty easy for you by now. If I take this point as M, okay, what is given is that E is midpoint. E is grammatically, if you want to correct, E is the midpoint of DA, right? And EM is parallel to AB. Why is it so? Because a line is drawn through E parallel to AB. So EF is parallel to AB. So we can say EM is also parallel to AB. Now once you can say these two things, then I can say by converse of midpoint theorem, by converse of midpoint theorem, right? I am writing these in short forms. M is the midpoint of side DB, right? I am taking this triangle DAB, E is midpoint of AD, EM is parallel to AB, so by converse I can say M is midpoint of DB. Okay, this much I have got. Now notice triangle BCD. In triangle BCD, M is midpoint of BD, right? MF is parallel to DC. This is parallel to this, right? Why is it parallel to this? Because AB is given as parallel to DC. EF we have drawn parallel to AB. So all three sides are parallel to each other. So DC is parallel to EF is parallel to AB, right? This is the statement that you can make somewhere to start the question. Okay, that DC is parallel to AB, DC is parallel to AB, EF is parallel to AB by construction, AB by construction, and then you can say that DC is parallel to AB is parallel to EF, right? Now M is the midpoint of BD, MF is parallel to DC, so what can you say about F? F is midpoint of BC by F is midpoint, F is the midpoint of BC by converse of midpoint theorem, by converse of midpoint theorem. Okay, or you can simply say that by midpoint theorem. Okay, midpoint theorem includes its converse also. All right, so F is the midpoint of BC. Now in a parallelogram ABCD, E and F are midpoints. So let me mark this information by symbols. E and F are midpoints. So E is a midpoint of AB. So I can say AE is equal to EB. You can keep writing this alongside. Okay, you can keep on writing this information here. Otherwise, if you mark it like this, it will be pretty easy for you to visualize the problem. Okay, E and F. So F is midpoint of DC. So which can be represented by these marks. 3 cuts here, 3 cuts here. Okay, and we know that this is a parallelogram. So we know that AB is equal to DC, opposite sides of a parallelogram. So their halves will also be equal. Okay, so I can mark all these because DF is half of DC, right? FC is also half of DC. So these segments are equal, and these are equal to these segments also, because halves of equals are also equal. So let me mark all these segments by 3 cuts here, or 3 bars, right? This much we have understood. Show that the line segments AF and EC trisect the diagonal BD. So what we need to prove, or what we need to show here, is that DP is equal to PQ is equal to QB, right? Now this question is very easy, because we know, if you notice this quadrilateral here, FCEA, FCEA, will it be a parallelogram or not? It will be a parallelogram, because FC is equal to AE, FC is parallel to AE, FC is equal to AE, FC is parallel to AE. This means that FCEA is a parallelogram. You can write its reason in detail, that if a pair of opposite sides is equal and parallel, then the quadrilateral is a parallelogram. I leave that part to you. Okay. Now this is a parallelogram. So what can you say about line AF and EC? These will also be parallel. AF and EC will be parallel lines. Now you notice this triangle here, DCQ. In triangle DCQ, This line PF is parallel to QC because we have shown it here. AF is parallel to EC. So this segment of AF, that is PF, will be parallel to this segment of EC, that is QC. So these are parallel, and F is midpoint of DC. So what can you say about point P? P will be a midpoint of DQ by midpoint theorem or converse of midpoint theorem, right? So in triangle DCQ, F is the midpoint of DC, PF is parallel to QC, hence you can say that P is the midpoint of DQ, right? So P is midpoint of DQ, that means DP is equal to PQ, right? Now I want you to focus on another triangle, triangle PBA. In triangle PBA, now what you know about this point E? E is the midpoint of AB. E is the midpoint of AB, and so E is the midpoint of AB, and EQ is parallel to PA. Hence, by converse of midpoint theorem, I can say Q is the midpoint of BP. So Q is the midpoint of BP, and if Q is the midpoint of BP, then BQ will be equal to PQ, right? So from here I said that DP is equal to PQ, and from here I observed that BQ is equal to PQ. So essentially all three segments, that is DP is equal to PQ is equal to BQ. Hence this statement is proved that line segment AF and EC trisect the diagonal BD. Trisecting the diagonal means that this part is equal to this part is equal to this part. This is trisecting. Okay. Let us move to the next question. Show that the line segment joining the midpoints of opposite sides of a quadrilateral bisect each other. Let us look at the question. Let us make a quadrilateral. Line segment joining the midpoints of opposite sides. So if this is a midpoint, this is midpoint, this is the midpoint, and this is the midpoint. Now this question can be done in seconds if you have listened to this lecture carefully. If I join the opposite points, that is this point and this point, and these 2 points, right? These two bisect each other. Now tell me, let me mark these points also. A, B, C, D, P, Q, R, S. Tell me 2 things. Number 1, if I take any quadrilateral and join the midpoints of its sides, what will be the quadrilateral that is made inside? It will be a parallelogram. This much is clear? Yes. Which this we have discussed ample number of times in this exercise. Okay, so this inside quadrilateral is a parallelogram. Number 1 thing. Second thing that you must know by now is that if I have got a parallelogram, and I draw the diagonals of a parallelogram bisect each other. So this segment is equal to this segment, and this is equal to this. If you know these 2 things, this question is you can do in 10 seconds. That if you join the midpoints of sides of a quadrilateral, the inside quadrilateral that is made is a parallelogram, and the diagonals of a parallelogram bisect each other. Now look at this. P, Q, R, S are midpoints of sides AB, BC, CD, and DA. So if I join these, P, Q, R, S will be a parallelogram, right? This statement you can make directly if this is a 1 mark question or 2 marks question. Otherwise you can prove it also by looking at the question number 1 of this exercise. So PQRS is a parallelogram, and PR and SQ are diagonals of a parallelogram, hence they bisect each other. Right? So what did I say? That PQRS is a parallelogram. Why? Because it is a quadrilateral made by joining the midpoints of a quadrilateral. Right? Or you can prove it also. Right? And the second statement I made, that PR and SQ are diagonals of parallelogram PQRS, hence they bisect each other. This is what we need to prove here. I hope this question is clear to you. Okay. ABC is a triangle, right angled at C. So let me make a triangle right angled at C. Let it be A, C, B. So this is a right angle C. A line through the midpoint M of hypotenuse. So this is M and it is the midpoint of AB. A line through midpoint M of hypotenuse AB and parallel to BC. So parallel to BC. These two lines are parallel. Intersect AC at D. Okay. So first part says that D is midpoint of AC. This by now you should be saying yourself. Why? Because M is midpoint of AB. M is and MD is parallel to BC. So by converse of midpoint theorem, you can easily say that D is midpoint of AC. So to prove the first part, you can say two statements, that M is the midpoint of AB. So you start with triangle. In triangle ABC. In triangle ABC, M is the midpoint of AB and MD is parallel to BC. Hence, by converse of midpoint theorem, you can say D is the midpoint of AC. First part is done, right? Now D is midpoint of AC. MD is parallel to AC. MD is perpendicular to AC. Now I know that MD is perpendicular to BC, right? So this angle here will be equal to this angle. Why? Because these are corresponding angles. Two parallel lines, transversal, so these two angles are corresponding angles. Angle D, so what can I say here is angle ADM is equal to angle ACB equal to 90 degrees. Why? Because these are corresponding angles. Right? So angle D is also 90 degrees. This angle is 90 degrees. And if this angle is 90 degrees, MD is perpendicular to AC. This is also proved. Now CM, MA and half of AB are equal. So if I join this CM, right, CM, MA is equal to half of AB. MA is half of AB. This is already given in the question. So we just need to prove that CM is equal to MA. MA is half of AB. There is nothing to prove in this. What we need to prove is that CM is equal to MA. Now see, if you have done the chapter on circles, it is very easy for you to visualize that if you take M as midpoint and AB as diameter, you can draw a circle, a semicircle, right? If you draw a semicircle passing through C, and it will definitely pass through C. Why? Because angle made in a semicircle is 90 degrees. So diameter makes an angle of 90 degrees at the circle. Okay. So this is one of the ways of looking at it, that MC will also be radius. So it will be equal to MA and MB. This is one of the ways. The other way, or the way that you will use here, is that you will consider these two triangles. If you consider, let us say, this triangle and this triangle, you know that this angle is 90 degrees, this angle is 90 degrees, this side is common in these two triangles and these two sides are equal. So you can easily prove that these two triangles are congruent triangles. Hence, by CPCT you can say this side is equal to this side, AM is equal to MC. So I want you to take these two triangles ADM and CDM. In triangle ADM and triangle CDM, AD is equal to CD, DM is equal to DM, common side, right? And angle between them, that is angle ADM, is equal to angle CDM. Hence, by side angle side congruence rule, what can you say? That triangle ADM is congruent to triangle CDM. Hence, by CPCT, you can say AM is equal to CM. AM is equal to CM by CPCT. Now, what is AM? AM is just the half of AB because M is midpoint. AM is just the half of AB. So I can say AM is equal to CM is equal to half of AB. AM equal to CM half of AB. Hence, it is proved. Okay. I hope you have got the idea of what the midpoint theorem and its converse is and how to use the midpoint theorem and its converse while solving various problems in this lecture, in this chapter. Okay. Thank you.